Okay, so now we're going to move on to the very last topic for fractions for this week. It's about the types of fractions. As you can see over here, we have 3 different types of fractions. The first one is called proper fractions. The second type is called improper fractions. And the third type is called mixed numbers, and it has another name which is called mixed fractions. So, what is a proper fraction? A proper fraction is a fraction, but the numerator is less than the denominator. This type of fraction is what we've been learning about and doing examples about. So as you can see, all of these fractions have the numerators less than the denominators. So they are called proper fractions. We already learned how to draw and model them. So now we're going to move on to the second type of fractions, which is improper fractions. It's almost spelled the same as proper, but there's an IM at the beginning. Improper fractions. What are improper fractions? They're fractions, but the numerator is greater than the denominator or equal to the denominator. This we only learned about when the denominator is equal to the numerator. Now let's see what we mean by when the numerator is greater than the denominator. Here's an example. Let's think of any denominator. 4 came to my mind. So now the numerator should be greater than the denominator for it to be an improper fraction. What's greater than 4? 5 or 6 or 7 or 8 and so on. So this is an improper fraction because the numerator is greater than the denominator. Now, also, when the denominator is equal to the numerator, this is also called an improper fraction, like this. Now, let's see when I have the denominator as 3, how can I make it an improper fraction? For example, 6. 6 is greater than 3, so in this case, the numerator is greater than my denominator, so this is why this is called an improper fraction. Now I'm going to model them with you in just a bit, but let's move on to the mixed numbers. What is a mixed number or a mixed fraction? The mixed number, from its name, it's mixed. So it consists of both a number and a proper fraction. A natural, normal number and a fraction, but the fraction in this case should be proper and not improper. Let's see an example. Let's think of any number, for example, 2. So I finished the first part of the mixed fraction, which is a number, and the mixed fraction also consists of a proper fraction for it to be a mixed number. So I go on again and draw the fraction bar. Underneath the bar, the fraction bar, I write a number, let's say 3. Above the fraction bar, I have to write the numerator. Remember, the mixed number consists of both a number and a proper fraction. So let's go back to proper fractions. Proper fraction means that the numerator is less than the denominator. So for the numerator, I have to choose a fraction that is less than 3. I chose 2 in this case. So how do I read this fraction? 2 and 2/3. For the case of improper fraction, I say 5/4, 4/4, or 4/4, 6/3. Now we're going to learn how to model these improper fractions and mixed numbers and draw them over here. Let's start with the first example, which is 5/4. I wrote it here. So we're going to model it. As we already said, we want to divide What's the denominator? It's 4. So I'm going to draw any shape. In this case, I chose a circle. It could be any shape you like. And then I have to divide it into 4 equal parts. But here's the trick. How can I shade? As we know, the numerator is the number of shaded parts. How can I shade 5 parts if the total number of parts is 4? Let's try. I shaded 1, 2, 3, and 4. I still haven't shaded 5 parts. So in this case, what do? I draw another shape. It should be the same shape. And I also have to cut it into 4 equal parts because the denominator is 4. So the total number of parts should be 4. And because I already shaded 4 parts, so I'm going to shade 1 more. And this is how I shade 5 parts. So this is how we model improper fractions. As you can see, each part is still cut into 4. So the total number of parts in each whole is still 4. And the number of shaded parts is 5. Let's move on to the next example, which is 4/4. This is simple because they're both equal. So let's see. The denominator is 4. I'm going to draw a shape. I'm going to cut it into 4 equal parts. I'm going to shade 4 parts. In this case, I did not have to draw another shape because this shape already fits 4. Now, the third example for improper fraction over here is 6/3. Let's move on to a rectangle. And that's divided into the... So what's the total parts, which is the denominator? 3. 1, 2, and 3. 3 equal parts. Now, let's move on to the numerator. I have to shade 6 parts. But how can I shade 6 parts if I only have 3 parts in total? Let's see. 1, 2, 3. I'm still not done. I only shaded 3 parts and I should shade 6 parts because the numerator means the number of shaded parts. So in this case, I add the same shape again. I should always divide it into the number in the denominator, which is 3. 1, 2, 3. Now I finished 3. I shaded 3. In order to reach 6, I need another 3 parts to shade. So let's double check. Each whole consists of 3 parts. So that's right, because my denominator is 3. Let me check. Did I shade 6 parts for the numerator? 1, 2, 3, 4, 5, 6. All 6 are shaded. This is how an improper fraction is modeled. Now, let's move on to the mixed number or mixed fraction. In this case, I gave only one example, but let's give another example. As we said, the mixed number consists of both a number and a proper fraction, because the proper fraction has the numerator less than the denominator. This is why the numerator is less than the denominator over here. So let's think of any other number. Let's say 3 and any proper fraction. So I placed 2 in the denominator already. The numerator should be less than 2. I'm going to put 1 for it to be a proper fraction. Now this is a mixed number because it includes a number and a proper fraction. Let's model these two over here. So I'm going to write the first example and then over here write my second example. So now let's model them. As we can see over here, first thing when I find a mixed number, I circle the denominator. Always, always, always circle the denominator to know how many parts to cut your shape into, or divide your shape into. In this case, I'm going to divide my shape into 3 parts. Think of any shape you like. Let's say a circle. I cut it. Let's pretend these are equal. Now, as you can see, over here I have 2. What does this mean? It means I have 2 holes. So I have to fully color this. This gives me 1 hole because it's all colored. Then I'm going to draw another fraction, which is divided into 3 equal parts because the denominator is 3. I'm also gonna color it all because I don't only have 1 hole, I have 2 holes. 1, 2. So now I'm done with the number. I represent the proper fraction. Cut into 3 parts. How many are shaded? 2. 1, 2. This is how I represent my mixed number. What does a hole mean? This is a hole and this is a hole. It means that all the parts are shaded. All of them are shaded, so this becomes 1 and this becomes another 1 hole. So 1 plus 1. This is why I have 2. Now, let's move on to the second example. Over here, it's 3 and 1/2. How am I going to represent it? As we already did, we circled the denominator, which is 2. How am I going to model it? I choose any shape. I divide it into 2 parts. Because I have 3, which means I have 3 holes, I shade all parts for it to become a hole. Then I have another shape divided into 2 parts. I also shaded. Now I'm done with 2 holes. I have yet another 1 hole for it to become 3. Now I have 3 holes, right? 1 hole, 2 hole, 3 holes. Now the last thing I should do is model the proper fraction. As you can see, they're all divided into 2 parts because the denominator is 2, even the holes. So now for the proper fraction, I only shade 1 part, and this is how I model the mixed fraction. Thank you all. Enjoy the rest of your week. See you soon.